All right, welcome to our newest Bitcoin whiteboard video. This is one that I've been looking forward to making for quite a while because it will appeal to anyone who would like to see Bitcoin scale, but who may also be a hater of things like the EVM, also known as the Ethereum virtual machine. Because by the end of this whiteboard video, I will show you how we can bring virtually any scaling solution to Bitcoin and how we can do this without having to introduce a new soft fork, even though one could be quite beneficial, how people can interact with this without having to touch the EVM or any sort of Ethereum-based architecture, even though it does have quite a few merits, and how eventually you can do this without being able to rely on any sort of entity, including ourselves at Alpen Labs, who are really kind of pioneering and pushing forward a lot of this research. Okay, so we're going to do a quick overview of the whiteboard, and then we're going to hop right into how all this is going to work. So as a reminder, Glock, which stands for garbled locks, is our Alpen specific flavor of BitVM 3. This is what allows us to create these very high security, very low trust Bitcoin bridges. Up here, we're going to talk about the different types of scaling solutions that exist, things like the EVM, things like Simplicity, which is a formally verified language from Blockstream, things like private payments with shielded CSV, things like micropayments for agentic finance. We'll talk about all of that. But really, the core net new thing that we're introducing is this kind of middle layer right here, which is going to allow us to bring any and all of these to Bitcoin in what we feel is a pretty elegant way, and that can meet the kind of different requirements and preferences of all sorts of different users. Okay, so let's go ahead and hop into it. First, we're going to start down here and say that there's users that want to take their Bitcoin and access some of these different scaling solutions. And so they're going to lock their Bitcoin into some sort of address. There's going to be some additional spending or locking conditions that are created when the funds are deposited. We're going to discuss that here in a little bit. Once the funds are locked, they can go up into any one of these different chains. For now, let's say they get minted into Alpen, which is our EVM compatible layer 2. At certain frequencies, all of the transactions on the EVM will essentially be compressed, and there will be a snapshot of the user's balances that are created. And along with that snapshot, there's going to be something called a zero knowledge proof, which is created. Technically, this is a validity proof, but colloquially, we kind of call it a zero knowledge proof. And so what this does is it takes the compressed snapshot, and it's like an unforgeable digital receipt that says this snapshot is valid, that there hasn't been anything that's kind of been manipulated or changed inside of this snapshot. And so it's cryptographically valid. Okay. So this snapshot in the ZKP is going to go down here to this entity, which we'll describe in a little bit. And it's going to find its way into the Bitcoin layer 1. And so it gets posted in what's called the inscriptions envelope. This is where people are posting kind of arbitrary data. Instead of posting JPEGs or NFTs, you can kind of post this compressed snapshot along with the zero knowledge proof. Okay. At some point in the future, users will want to withdraw from the, EVM compatible ecosystem. Okay. And so if necessary, there is this separate process that we call Glock. Okay. And what this does is when the users had deposited their funds in here, these separate pre-signed transactions were created, and they have this thing in them called a garbled circuit. Okay, this is what I attempt to draw what a garbled circuit looks like. And the garbled circuit can be paired with the zero knowledge proofs that have been getting posted down here. So we'll just look on the Bitcoin blockchain, pair the existing garbled circuit with the zero knowledge proof and with the withdrawal request, and it will essentially return either a true or a false. And so the garbled circuit is essentially verifying the validity of the withdrawal. And if it is in fact valid, meaning it's honest, then you may proceed and you can withdraw your funds back to the Bitcoin layer 1. If it is false, it blocks it, it's a malicious withdrawal, then nobody can steal from the bridge. Okay. The caveat here is that there's only a set number of parties that can use this Glock style setup. And these are what we call bridge operators. So if, for example, there are 10 bridge operators, even if 9 of them are malicious, as long as there's one single honest operator that is willing to run this garbled circuit, then the bridge is cryptographically secure. Okay. So users will never touch this. The bridge operators will handle all of this on their behalf. And it's that one of n trust assumption. Okay. So one of n. Okay. So it's not technically perfectly trustless and a true unilateral exit, but I would say it's very, very strong and strictly superior to the kind of existing bridges that we have in Bitcoin land. Okay. All right. So now we've created this. There's a bunch of people that may say, hey, this is pretty cool. This is a very high security bridge, but I don't want to use the EVM. And so maybe people say, well, can I get access to, privacy, maybe something like shielded CSV Or what about simplicity? Okay. What about simplicity? Or maybe somebody says, I want to go to Ethereum because there's the all the network effect and liquidity is there. And maybe I want to go to do like, high frequency microtransactions for agentic finance. All of these have, valid considerations. So what they could do is they could build a bridge from Alpen to maybe simplicity or from Alpen to shielded CSV. But some people may not want to do that because they're like, then you have to actually go through the EVM and I don't really like doing that. And I don't want to be reliant on any sort of Alpen infrastructure. And so I'd rather just go direct. So maybe what you'll see is somebody just kind of duplicate some sort of garbled circuit style bridge like we have down here and just build it directly into simplicity or directly into privacy or directly into Ethereum and so on. The problem with this is it kind of creates this fragmentation. It creates all of these independent siloed bridges that can't necessarily talk and communicate with each other. You could do that, but it kind of reduces the interoperability and the ability for these to kind of communicate or transfer value between each other. And that problem has proven to be quite an issue, as we've seen in the Ethereum ecosystem. And so I think we'd rather not replicate it on top of Bitcoin. A superior solution is if you could just use one bridge or one layer that anybody can essentially tap into. And so one, you don't have to duplicate all of the resources, but you also create this system where now you don't have this fragmentation issue and all of these different solutions can communicate with each other. Okay. And so the reason you could do this is because a zero knowledge proof is a very, very flexible tool. It's not just an EVM specific thing. You can create zero knowledge proofs out of pretty much anything. You can take any sort of arbitrary computation and you can compress it into that snapshot that we talked about and then prove that it is essentially valid. And you can do this for simplicity. You can do it for, high frequency microtransactions, for privacy, etc. Okay. So now we have this setup where all of these can create their own zero knowledge proofs. Let me draw all these out. Okay. So all of these can essentially have activity that's happening up there and they create these zero knowledge proofs. And you can also think of these zero knowledge proofs as essentially translation tools. They translate whatever language is happening up here in these different scaling solutions and they translate it into a common primitive that all of these can now understand each other. Okay. And so because of that, these can actually all be aggregated. Okay. So all of these can kind of communicate and be aggregated into one joint ZKP, okay? The next thing that we have to consider is that there will be different Bitcoin balances that exist across all of these different solutions. So let's just say here there's 3, 2, 5, 4, 1, what is that, 4, 5, okay, 15. So that's 15 BTC that exists across all of these. And so you need some sort of ledger or some sort of way to track the different balances that exist within each one of these accounts, okay? And the way that we do that, a ledger, is with a blockchain. So here, this entity is actually a blockchain. And so this may bring up some questions in people's minds where it's like, okay, we're introducing another new blockchain. Is that an EVM? Like, does that have a token? And does it have proof of stake or a consensus system? And the answer is like, no, it doesn't really have that type of mechanism because this is an extremely lean and stripped down blockchain. It's hyper minimalist. To start, it's technically a rollup, okay? And the reason why a rollup is beneficial is because a rollup is a type of blockchain that lives inside of its parent blockchain. It lives inside of essentially your Bitcoin layer 1 nodes. And because of that, by definition, it inherits what's called the double spend protection, the consensus, and the finality of its parent chain, in this case, Bitcoin. That's another way of saying it truly inherits Bitcoin's security, okay? So we don't need to introduce any sort of new proof of stake token or consensus mechanism. Then you may ask, well, does it have some sort of programming language like the EVM? And are people going to be able to deploy smart contracts and dApps and other things into this blockchain? And the answer is no, okay? Because really, the only thing that this blockchain can do is it can create these accounts, which we call SNARK accounts, okay? SNARK accounts, okay? In the same way that on Bitcoin or another blockchain, you can spin up like a wallet and it holds a balance and you have a private key to be able to send or receive funds from that. These SNARK accounts, you can spin up essentially accounts that can hold Bitcoin balances in them, but the only way to modify or change it is with a valid zero knowledge proof. So every time a valid zero knowledge proof, maybe from this chain happens, then the balance can essentially tweak and be changed. And this idea of SNARK accounts was actually, we'll give credit, I believe it originally came from the Celestia team, and they have a primitive that they call ZK accounts, okay? And so because of this, now, because they're all using kind of a similar primitive, all of these can actually talk amongst each other, okay? And they can more easily transfer balances, okay? And so this is now actually quite an elegant solution because it allows all of these, again, different solutions, which may have certain preferences, to all use one common bridge, but to not isolate themselves and fragment the liquidity away from a kind of master source. And so much of the work that we've been doing at Alpen Labs over the past handful of years, of course, has been very heavy on what we call Glock or these kind of BitVM family of products, because that was the core innovation that was needed. We've also been kind of building out this EVM layer, but so much of the work that we've actually done is basically creating a separation between what we call the orchestration layer here and the execution layer. So this is actually what we call at Alpen Strata. Okay, Strata is this orchestration layer. And then up here, it would be more of this execution. This is like where the different types of execution layers can actually exist. And so while we at Alpen can be hyper opinionated about our EVM, we can say it's strictly for financial activity, and those are the use cases that we're pursuing. In the process, we kind of created what we hope to be this kind of neutral layer that we can just give to the Bitcoin community, and people can use it independently of ourselves. Okay, so that is the idea. It does get, I think, even a little bit better. And so to kind of understand how it gets better, I need to explain like the anatomy of different types of blockchains, right? And then we'll kind of apply this up here. So every blockchain has some sort of execution environment. Okay. In Bitcoin, this is basically like the scripting language, right? We would call this Bitcoin script. This is like where you can use opcodes to do certain limited functionality in Bitcoin. There's also something that I'm going to call the sequencer right here. Okay. In Bitcoin, the sequencer is basically the miners. The miners are competing to win the Bitcoin block every 10 minutes. If they win it, they essentially get the privilege to be able to put transactions from the mempool into the block. Technically, they could put them in a certain order. Other blockchains have a similar role. Okay. Then you have what I'm going to call here validity. Okay. This is how do you check that transactions are essentially valid, that the person who actually wants to send the value does in fact have the value, that there is a proper private key that sent that. In Bitcoin land, after the miners place the transactions in the block gets sent to the nodes. The nodes are kind of checking the validity of all of those different transactions that exist in the block. Okay. And then the last thing that I'm going to say here is I call it DA, which some people call it data availability, but really it's just the state. Okay. And so in Bitcoin land, after the nodes receive the block and they've checked the validity, they append that block onto the blockchain, and then they look at all of the past prior transactions and they say, hey, the newest, most updated state, what we call the UTXO set, here's the newest state. Okay. And so all of these different chains, they can make more decisions aside from just the execution environment that they want. They could say, well, yes, we want to use simplicity, but we also want to be very opinionated on other parts of the blockchain stack. Okay. So for example, us at Alpen Labs, when our EVM goes live, we will start by having one single sequencer. We'll also have our DA or our state. We will post this on Bitcoin. So we'll post our state, our snapshot on Bitcoin layer 1. The way that we get validity is with a zero knowledge proof, right? There are some other chains who may say, like shielded CSV, which is privacy related. They say, we don't want to have any sort of centralization vector whatsoever. So maybe for their sequencer, they say, hey, we want many different sequencers. We want this decentralized sequencer set. They may also say, hey, for our DA, our state, we need to post it on Bitcoin because we need the high security. And maybe for their validity, they say we need a certain type of zero knowledge proof that actually maintains privacy. And something like the EVM, the types of zero knowledge proofs that we use, they give you validity, but they don't give privacy. So they may have, let's say p.zkp, right here is the type of validity that they need. Simplicity, or let's use microtransactions here, may take a different approach, right? They may say our sequencer, they're like, we want 1 millisecond, hyper fast, high frequency trading. So we want one sequencer. And they say for our DA or for their state, they're like, if we post it on Bitcoin, there's limited block space on Bitcoin. So transaction fees are going to go up. And, they're doing high frequency, millions of transactions per second. So maybe they use like some sort of, federation type thing, which adds trust, but it gives you higher performance. And, maybe they want, a certain very fast proving ZKP scheme. Okay. The point I'm making with all of this is this entire stack allows every single person to be highly, highly opinionated. It's not requiring anybody to say, you have to use this sequencer or you have to use this data availability solution. You have to use this type of zero knowledge proof. It's like, build whatever the heck you want. And then you can settle into this kind of Strata orchestration layer, and all of the bridge stuff will be handled on your behalf. And then, by the way, you can also, if you want, get additional layers of interoperability or shared liquidity amongst different types of chains. Okay, so that is pretty much the whole whiteboard. Some additional things that I just want to mention, because they could be seen as gotchas, is this whole setup. For us at Alpen, this is basically exists on Signet. Okay, so it's live on Bitcoin's testnet. I imagine people won't actually start deploying new types of chains until, I don't know, probably next year, if at all. But it's not yet live on mainnet. The other thing is, for now, this entity right here, this blockchain, it needs what's called a block builder, or kind of this sequencer. And so for now, it would be one single centralized sequencer. And so that would be Alpen Labs' sequencer. There is a path to get it to multiple or many, or kind of a decentralized sequencer set. And I think that would be the ultimate goal. Otherwise, you're defeating some of the purpose of this architecture. The other thing I'll say is our specific kind of what we call the garbled circuit, or Glock. There is a role, I discussed this in prior videos, something called a security council. And so what the security council can do is, if there is some sort of bug that is seen in the garbled circuit, some sort of cryptographic bug that we did not expect, there is a time lock that happens on all of these withdrawals. And during that time lock, the security council could sweep the funds from the address as an emergency and sweep it into a predefined address. What the security council cannot do is essentially send those funds, to any certain address. And so that does introduce some additional level of trust, at least in the short term. For us at Alpen, that's just the security posture that we're taking. Maybe once these bridges are a year or two in, and we have things like formal verification, and you can really, really prove the robustness of the security, that would be removed. But those two things of relying on the single sequencer in the interim and having the security council, I think, are important security considerations that people would want to know. Let's see. Maybe the last final thing that I want to say here, I kind of alluded to this, but within this architecture, there are certain scenarios where if certain scaling solutions maybe want to opt into certain types of shared architecture, maybe they want to use the same sequencer, or maybe they want to use things like the same prover, you can get additional higher levels of interoperability. Maybe that means you can transfer funds between these chains faster, or maybe it means they can actually share liquidity as if they were a single chain. Those are a bit more advanced topics, but all of them are essentially unlocked by this idea of having one shared orchestration layer and being able to use zero knowledge proofs as these very succinct ways to communicate amongst each other. All right. So I say this a bunch. I think this is the most exciting thing happening in Bitcoin, and I hope people will see it the same way. So feel free to drop your questions in the chat, and I hope you enjoyed it. Thanks.